So here is the Delta bandsaw that I converted to metal cutting. I did that with a jack shaft and some pulleys, and it works great. I think it's about 150 to 200 feet per minute, but anyway, I have to push metal through here, and that works fine. The situation is you have to sit here and push and push and push. Now this is part of a rocket stove. And I have to make a cut like this, and then I have to make a cut like that, and then I flare these sides out, and this becomes the top of the rocket stove. Now, what I did was, I made a jig for this. So this goes like this, and this goes like that. It's a little tippy right now. The saw is not actually in position. Usually I have it turned the other way, but what I want to do is, I want to make an auto feed mechanism for this, because what you have to do is you have to push and push and push, and then you turn this and you push and push and push, and it's not so bad to do one like this, but I usually make 20 at a time. Here they are here, and that means I got to make 40 of these cuts, and it gets tiring. So what I thought I would try to do is make an auto feed mechanism for this thing. My idea is to have a pulley here and then a rope that pulls, and then out here, down here, there would be a weight to pull this down. So I'm going to try that. So what I did was I took a skateboard wheel. This is a skateboard wheel that I had lying around, and I put it in my lathe, and I made a cut. Well, you can see here, I think, how I made this cut. Yeah. Just kind of worked this back and forth. I had to do this really slowly because I had a very slight grip on this spongy urethane. But anyway, I made a groove in it for the rope. So I have this piece of channel, and I discovered there are two threaded holes in the front of this Delta, and they're 1/4-20 threaded. I wasn't sure what they were. I cleaned them and ran a couple of different taps through, and I discovered they're 1/4-20. And I want to attach this, I think something like this. I might drop it down a little bit so I can get the guide through without. Will this work? Yeah, I think that'll work just fine. If I drop it down enough, I won't have to make a cut here. All right, let's try that. I've got my headlight on, which I've discovered makes things a lot easier. These holes don't have to line up perfectly. I can make an adjustment after I drill them. I'll try to get them close. I might drill them 5/16. Using a prick punch, I feel like it gets me a better view of what I'm doing. Then I'll enlarge it with a regular punch so the drill bit can catch it. Probably don't need to do this second punch, but okay. I'm going to drill this 2 drill sizes up from 1/4 inch to give myself some wiggle room. Let's see, what would that be? 9/32. So, very close to 1/4 inch, but 2 sizes up. works, but that's clearly too fast for drilling in steel. I think I'll slow this down a little bit, switching the belts. Better. Now that was nicer. I got a couple of 1/4-20 bolts. Let's see if I can make these go in or not. There we go. Yes, they are going to go in. And I am glad that I drilled them bigger. Now, let's try putting the sled on. It works. Okay, now I want to weld this here. The question is, where do I pull from? Do I pull it along its track? Or do I pull it where the saw is going to make pressure? I think I'm going to go in between the two. So I think I'm going to make it something like this. Then I can drill a hole through this and run my rope through. Oh, you're right about somewhere right in here. Well, let's give that a try. Okay. Okay, everything's cooled off now from the welding. I've got my rope. Put that here for now. Let's see, with the drill. Rope. And let's put, oops, there she goes. Let's put our skateboard wheel on. Let's see, a washer, a standoff. Is that the way it goes? Or does it go? I guess it could just go like this. Right. Another washer. And the 5/16/18 nylon lock nut. Let's put that on. We can do it. There it goes. Okay. This doesn't have to be tight, really. All it has to do is allow this thing to pull. And that should be just fine. Okay. Now, the rope, got kind of a tear there. Some nylon rope that I had laying around. And you think it goes like that. So let's drill a hole. And let's drill a hole right about here. I should think. Yeah. Can I get through here? I don't know. Maybe. Now, this is rather loose, so I'm going to put some screws in from the bottom. Okay, that should make that a lot stronger. That's where the rope will be pulling. I didn't want that to tear off of there. Okay. course I'm hitting the screw. All right. So, of course, I hit that screw. So I'm going to back it out. I'm going to run the rope through. And then screw it back in again. Oh, that's not the rope. The screw out, the screw is out. Okay. Yay, it went through. Simple knot in one end. The screw's got to be screwed back. Ooh, that's not the screwdriver. My daughter bought me this little pencil torch. It is cool, I have to say. Groovy little thing, which I've only used a few times, and whenever I use it, it's like, nice. Okay. Let's screw this back in again. And we got this action here. Okay. So I have my piece that I need to cut the slot in. Put that here, and then I bring that up to the saw blade till it stops. Clunk. And then I measure this gap here with a feeler gauge till I get a little drag. I've previously measured this with my calipers. That's 1.5 inches, and it says 1.5 inches here in case I forget. So, okay, that's in. Now, I'm going to tie a 2.5 pound weight to this drop. I think that's going to be not nearly enough. I think I'm probably going to need a 10 pound, but we'll try 2.5 to start, and we'll see what happens. I don't know if this is going to work, but I think it just might. It might just work famously. Okay, let's take a look at this thing. Where's the whole Magilla right there? 2.5 pounds pulling the thing. And I'll put a little cutting fluid on the blade, and let's see what happens. Yeah, that feels like, well, let's give it a try. That feels like 1/4 of what it should be. A little cutting fluid on the top of the part and some on the teeth. It actually might take 25 pounds or 50 pounds. I don't think so. But 2.5 pounds was barely tickling the metal. So now we're going to try. Let's try this. See what we get. Gotta have enough to go over. This should deliver actually better results than pushing by hand because it's so steady. It's so even. Okay, There's 10 pounds. Feels pretty good, pressure-wise. Pull it back, drop the part in, some tap fluid, metal cutting fluid, to start it up. Put a little on the blade. Well, that works great. The 10-pound weight with the nylon rope to the skateboard wheel, the axle welded to some half-inch plumbing pipe. I believe that's half-inch black iron pipe. Welded to a bracket, bolted to the bandsaw, the table, and then pulling the sled. Probably I should have something to hold down the steel. The steel is in a V-groove, so it can't go anywhere, but probably there should be something clamped. But you might ask, why don't I just, instead of mounting this to the bandsaw itself, why don't I just pull it from another machine? Well, I think that would pull, 10 pounds would pull the whole machine over. You know, you'd be pushing the sled and you'd get out. The whole thing would just go this way. Oh, maybe not. But this gives me a constant pull wherever I need it to go. So that's that video, and I hope this helps you. Don't forget to like, comment, and subscribe, and I will see you next time.